Okay, I'm going to assume that the glitch that interrupted us wasn't happening when I was doing the piecewise function. If so, I'm gonna have to come back and redo that when I'll save that board and make sure I can do that. Okay, so again, I'm gonna start over in this. Okay, the functions that we have a number 104, the points that I give you are not all that good. Okay, and I'm gonna have to kind of redo that particular problem. It won't be any trouble to do so, but it's gonna have to be done. We're gonna stick with what we have here. So you're given the coordinates of 4 points, I believe. Well, we put those coordinates on a table of y versus x, y equals f of x versus x. So we plot those points. Well, first of all, we take the standard 4x4 rectangle and subdivide or use construction lines, same construction lines that we would use for the reciprocal function. So those construction lines are here, they're all labeled. If you want to see them labeled step by step, look at the longer video. And when we do that, we get a point here, a point here, a point here, and a point here. So we can fit a nice smooth curve to those 3 points. Now, turns out that the inverse function, which is what you get now, what do you think when you think inverse function? You think swap x and y. Okay, so when we swap x and y, this column becomes this column, and this column becomes this column. And there is a table for the F inverse function. We plot those points. Now, 2 of those points are identical to 2 of these points. Graphs actually cross at this point and at this point. Okay. But there they are. And what we want to do then is answer some questions and make some estimates. Okay, so we're asked to estimate F inverse of 1.6. What do? We sketch the line x equals 1.6, which is right here and should be labeled somewhere. Here it is. Oh yeah, I'm sorry, here it is. This is line x equals 1.6. I could make that a little bit clearer. I could find some yellow chalk. See if this is right. Okay. Yeah, this actually looks pretty well. Okay, so the line x equals 1.6. We see where that line intersects the blue graph, which is a graph of the inverse function. And that's going to be at this point, and we then draw the horizontal line through that point and estimate y. It's between 1 and 2, pretty close to 2, so we estimate 1.9. Well, similarly, having estimated that, we let F, we let S equal 1.9, and then we find F of S. S being 1.9, that means we're finding F of 1.9. And we do that with the line x equals 1.9, and we do an estimate. We kind of estimate that F of S is also 1.9. Turns out that's not a great estimate. Not terrible, but it's not great. Okay, then we do F of 0.8. In other words, find F of 0.8, and we estimate 0.7. There's our line x equals 0.8. Here's a horizontal line through where this line intersects the white graph, and we estimate that we get y equals 0.7. And then we plug that number into F inverse. We get inverse of 0, F inverse of 0.7 equals 0.8. Well, this shows us, for example, that F inverse of f of x, which is what this is, R is F of 0.8. So that F inverse of R is F inverse of F of 0.8. Okay. And for some reason that all got smudged out, I would have to write it a moment. F inverse of F inverse of F of 0.8 is F inverse of 0.7 according to our estimate. And according to our estimate, this is approximately equal to 0.8. In other words, if X is 0.7, which I didn't label, but it's right here, you find that intersection. Now it's kind of hard to read all that on this graph. And I'm going to redo the function so that the f function kind of either goes up here or down here. And then the f of x function will either go up here or down here, opposite to the f of x function. And of course, that's the way inverse functions and original functions articulate. Okay, number 105. So it's actually a fairly simple problem, but you got to understand what this S thing and F and then this R thing mean. You can just follow the directions and that's okay. Just keep your wits about you and follow the directions. Okay, number 105 is just a simple function. You got f of x equals negative 4x minus 4. You want to find the formula for f inverse of x. What do? You swap x and y. So you take y equals 4x minus 4, y being equal to f of x, which is equal to 4x and negative 4x minus 4. You swap x and y, and there it is. Y becomes x, x becomes y. Solve it for y. Steps are simple. Although I messed it up several times in the original video. Okay. I kept looking at the wrong function. My attention was not where it ought to be. I think I was getting hungry at that point. I kind of recovered after that. So you get your f inverse of x here. And then you're asked to verify. Well, how do you verify this? You verify the two functions are inverses by applying f to the inverse function and seeing if the result gives you x. And then by applying the inverse function to the given function and seeing if you get x. If both of these are so, then you have a valid inverse function. And it's pretty easy to verify this once you understand and remember. You're going to have to remember it, so I'm not going to tell you the test. This is your test for inverse functions, not your test for the test. Okay, well, f of f inverse of x then is what? It's go to your f of x, lose track of where f of x is, go to your f of x, and you're replacing x by f inverse of x. So you replace this x by f inverse of x, as we've done many, many times in class. That's the way I've always explained it, and I hope you understand it. If you don't, I hope you understand it some other way, but there it is. So again, x has been replaced by f inverse of x. We're going to replace this x by f inverse of x. So we do. And f inverse of x has this formula, there it is. And then we do the algebra and we end up with x. And then similarly, f inverse of x is what? Well, f inverse of x is this. Replace x with f of x, and we get this. Then we replace f of x with its formula, and we get this. And we do the arithmetic, and we get x very quickly. So we have verified it. So I could have put a couple of check marks in this, I never did. So we'll check these all, okay? They both work. We've verified that we do have inverse functions. All right, now that brings us to the biggest problem, which is one of the problems, 101 through 104. Now, my original video, I took an hour and a half to work through this. Okay, so there's a lot of explanation, and if you don't understand it very well at all, it wouldn't hurt you. Do that whole video because you're going to have two problems between from 101, 102, and 103. Might be different two problems than the two somebody else gets, but you do exactly the same thing other than your construction of the function. You're going to get exactly the same questions for each of the three functions. So you can predict what you're going to be asked. It's totally predictable. People did a really good job on the first day of constructing the scoring function. Did a really good job on the second day with a quiz. Okay. And after that, a lot of people tended to forget what they've done, despite the fact that, I've been telling you. So here it is. Okay. And you did it. And now my main point there is, even if you forgotten it, you can review it and you can update it and upgrade it so that you can do it for any of these functions. Now, I'm doing it here for the, which function is it? Let's see, let me look at the graph. Yeah, it was a reciprocal function, okay. So this is version 4 sample problem bank. I think 101, the 101 function that I chose to do is the reciprocal function, okay? And this goes with one of the other videos, but right here. No, actually. Okay. That I think is part of what I did for this function, but here it is in all its glory. Okay. You don't necessarily have to write things out in all the detail that I did, but the one thing you do want to do is this is the reciprocal function. You graph the reciprocal shape. Okay, I didn't give you a scale right at the beginning, although I did later tell you that the red dot is at 16, -12. On that particular sample, you're going to probably get a different set of coordinates for HK. You're going to have to be able to do this, whatever H and K are. Anyhow, I've subdivided this and labeled all my construction lines for a reciprocal shape. Okay, and you have to know how to do that. I'm not going to explain that here. I probably did explain it on the longest video. Okay, so early on that video, so if you don't remember, you can look there, but we've done it a number of times. So you should know that, have it in your notes, and so forth. Okay, so we construct the thing, we label all the construction lines. Now, right now, it would be only the white lines, because the construction lines are in white, and then other lines that we use to answer the questions are in other colors, purple. What's that called? Yellow, yeah, orange. Okay. And we've labeled those lines as well, but let's see why we made them. Okay. Now, first thing, you label it, and then I tell you that the red dot is at 16, -12, which means the vertical line through the red dot is x equals 16. The horizontal line is y equals -12. From that, you get your labels. I'm not going to explain it, but there they are. And it should be obvious why the labels are what they are. 2 units on this side of x equals 16 gives you x equals 18. 2 units to the left gives you x equals 14. Similar for y. Then I ask you to label the construction points. Well, the construction points are here, here, and here, 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 and here, and right there are their coordinates. That's it. Okay. Now, I'm not sure in what order I asked these questions, but I'm pretty sure that we asked first to estimate g of x estimate the x value that makes g of x 13.3. So I gave you g of x is 13.3, which means y is 13.3. So we draw the line y equals -13.3. It intersects the graph here. We draw the vertical line through it, and there's the x that corresponds to y equals 13.3. It's 15 1/4. Okay. And then I ask you to do g of 14.7. Now, hopefully you have the copy of the sample problems in front of you, so you know how the questions were asked, and you can relate it to what you're seeing here. Don't, and I recommend you access that. I think I emailed it. Not sure I posted it, but I might well have posted it. Okay. Okay, anyhow. What's g of 14.7? Well, 14.7 is x. So you get x equals 14.7. You draw the vertical line for x equals 14.7. It intersects here. Here's your horizontal line. You get y equals -12.8. So you get this. Okay, so right there are the answers to the first 2 questions. Then we ask for the average rate of change on the interval 17.1, 17.5. What does that mean? That means we take the x interval from 17.1 to 17.5. Here's x equals 17.1. That's this line. Here's x equals 17.5. It's this line. You want to have those on your graph. You can even carry colored pencils if you want to distinguish the construction lines from the other lines, but you don't have to. just put them in the right place so I can see what you've done. Okay, I know where to look, and I'll know if you've labeled them, what line corresponds to what value of X or Y. Okay, so anyhow, now to get the average rate of change on this interval, for here two X values, you know that the change in X is going to be from here to here. And of course, that's 0.4, 17.5 minus 17.1 would be the calculation, which is pretty obvious. Go from 17.1 to 17.5, you got to go 0.4 units. 0.4. Okay. The 2 points on the graph are labeled, are here, and we got orange X's on them. And you have the Y values here, so you can determine what the Y value is for 17.1, Y value for 17.5. I'd like you to draw that triangle. Now that triangle is awful small. So what we do is we take the X and Y values from the triangle and we label just a separate triangle out here. We don't have to have a rectangle around it. We don't have to have coordinate axes. We know that this point is 17, negative 11.1. And this point is 17.5, negative 11.3. Now, when I originally wrote those coordinates, it was obvious that they went with the points. But I kind of put a lot of stuff in between the labeling and the points. But it should be clear that this is this point and these coordinates correspond to this point, so that we can find the rise and the run in the usual manner. And that means, of course, the rise is delta Y, the run is delta X. So delta X is the run, which is negative 0.4. And I don't know why I put a negative on that, but it's wrong. So there's another error you might want to make note of. You see that in the longer video. The run is 0.4 and the rise is negative 0.2 using these coordinates in a straightforward manner. The average rate of change on this interval then is the delta Y over the delta X, which is negative 0.5. And then I put down here, notice this coincides with rise over run equals average slope equals delta Y over delta X, which is your average slope. It's not bad to note that, but I'm not requiring it. And of course, that the average slope represents the average rate of change. So this whole statement here would be a nice thing for you to add, show that you have that insight. You put it in your own words, but there it is. Okay, but it's not required. If you did put that statement there and that you'd made some small errors someplace else, maybe even two small errors, I'd probably forgive them because you put that statement there. So you kind of cover yourself a little bit. If you would include that statement, it's good for you to know that statement. But again, it's not required. If you want to forget about it for now, that's okay. It'll come up later. Okay. So now you want to get the g of x equals f of x minus h plus k form of the reciprocal function. Okay, well, the reciprocal function is 1 over x. I did say the toolkit reciprocal function right at the beginning of the problem. You can see that if you look at the problem. G of x is f of x minus h plus k, where h and k is the set of coordinates of the red dot. Okay. Where's the red dot? It's at 16, negative 12. There's your G of x function. If you want to see more detail, because we'll go into more detail in explaining this. It's very important. Look at the longer videos. Okay. Then what do we do with that? Well, we come back over here. We're going to make a table of what G of x tells us. Okay. Just to verify that we've got the right function. G of x is 1 over x minus 16 minus 12. We plug in 14, you get 14 minus 16, which is negative 2. So you get negative 1/2, and negative 12 gives you negative 12.5. And look at that. That makes what you have here. Now, here, I want to see all the calculations. It's important for you to know how these calculations are done because you're going to get algebra. It's a whole lot like these calculations. And if you don't understand these calculations, when you get to the algebra, you don't understand the algebra much better. It's going to be less of a stumbling block for you, and it can be a stumbling block. Okay, so anyhow, this table turns out to match this table. This table came from your construction points, very easy to make. Okay, this table came from your inverse, from your composite function. The horizontally and vertically shifted reciprocal function. Through calculation, through calculating this for each x value. And the calculation is very easy, but you've got to know the rules that we're going to take. Okay, now I haven't been able to look back at the video where we were interrupted. I'm going to do that now. So if there's something missing, I'll go back and pick it up. Okay, so that's a quick synopsis. I think that should be 30 minutes or less. Quick synopsis of what I did in 2.5 to 3 hours on the original videos, about 90 minutes on the shortened videos, and now we're down to 30 minutes. So if you can understand everything based on what you've seen in this, well, these 2 videos because of the interruption we had, which ought to total about 30 minutes. Yeah, if you understand everything, everything's clarified at this point, you don't really need to watch the rest. If there are things you do need to watch, at least then you'll know where to look. Okay. Okay, so good luck, practice, and do a good job on the test. It is achievable. Some problems are a little harder. I think the composite function, deconstructing composite might be the hardest thing. Everything else is pretty straightforward if you practice it and know what's going on. Okay. So good luck again.